I don't claim to know whether aliens exist or not. I haven't examined all the evidence in the universe. I haven't been everywhere. But the interesting thing about science, and this is crucial, is not to prove what's impossible and what's possible. That's not what science does. Science is about what is more likely and what is less likely. It's about probability. It's about reasoning from what we know about the world. And when someone asks me, is it impossible that there are flying saucers? I can tell you honestly, no, I can't prove it's impossible. But I can tell you what is more likely given what we know. You see, there's a very common mistake people make. They think that if you can't prove something is impossible, then it becomes equally likely as something else. That's not how it works. That's not how science works. The business of science is in establishing what is more probable and what is less probable. And I want to walk through why I think, based on physics, real, honest-to-goodness physics, why certain ideas are very much less probable than others. Let me start with something basic. The universe is vast. And I mean vast in a way that your intuition, your human intuition that evolved for walking around on the surface of this planet, simply cannot grasp. You know what I mean? We evolved to judge distances of, a few miles. Maybe we'd see a mountain range at 20, 30 miles away. Our intuition works for that. But when you take that human intuition and apply it to the scale of the universe, it doesn't just fail, it snaps. It completely breaks down. There are, we estimate, about 100 billion galaxies in the observable universe. Each one contains roughly 100 billion stars. Most of these stars appear to have planets around them. Now, think about that for a moment. That's a staggering number of worlds. And you know what? I think life probably exists in profusion throughout the galaxy. When I look at the evidence, and the evidence is quite good here, I see that life arose on Earth very quickly. As soon as the laws of physics and chemistry allowed it, with just water, sunlight, and organic materials, which exist in abundance throughout the galaxy, life appeared. So if all these ingredients exist out there, I would expect that life, in some form, exists out there too. That's not unreasonable. But, and this is a big but, there's a profound difference between life existing somewhere out in the universe and that life coming to visit us. That's a very different question entirely. And here's where the physics gets interesting. Let's talk about interstellar travel, which is what would need to happen for anyone to visit us from somewhere else. The first problem is distance. The nearest star to us, besides the Sun, is Proxima Centauri, and it's about 4.2 light years away. Do you understand what that means? It means that traveling at the speed of light, which you cannot do if you have any mass, but let's say you could, it would take you 4.2 years to get there. The next star is even farther, and the next. Space is really, truly big. Now, some people say, well, maybe they have faster engines. Maybe they've figured out how to go faster than we think is possible. And here's where I have to tell you something important about the nature of reality itself. The speed of light isn't just a speed limit like, say, the speed limit on a highway that you happen to obey. No, the speed of light is a structural limit of reality itself. It's the speed of causality. Let me explain this more carefully. When you push harder on the accelerator of your car, you go faster. Simple. You put more energy in, you get more acceleration. This is the world we're used to. But near the speed of light, something very strange happens. The laws of physics change. You see, as you accelerate an object toward light speed, that object's relativistic mass increases. It gets harder and harder to push. And the faster you go, the more energy you need for each little bit of additional speed. To reach light speed, to actually reach it, with any object that has mass, any object with any material in it, would require infinite energy. I mean infinite. Not just all the energy in the sun, not even all the energy from all the stars. Literally infinite energy. This isn't an engineering problem. You see, that's the crucial point. People think, well, maybe some advanced civilization figured out a clever way around this. No, these are the rules of the universe itself. Einstein worked this out, and every experiment we've done confirms it. A civilization millions of years ahead of us would face the same boundary, the same limitation. Because it's not a limitation of their technology, it's a feature of space-time itself. Now, let's think about what this means for travel. Even if, and I'm being very generous here, even if a civilization could somehow travel at, let's say, half the speed of light, which would be an extraordinarily technological achievement, It would still take them at least 8 to 10 years just to reach the nearest star. To reach us from somewhere interesting, from somewhere far enough away to have possibly developed their own civilization independently, it might take thousands or millions of years. And here's the rub. Civilizations don't last forever. Think about it. How long has humanity been technological? A couple hundred years? That's it. 200 years. The universe is 13.8 billion years old. We're a flash, a blip, and it's quite likely that civilizations, if they arise, are also relatively brief. They might last a very long time by our standards, thousands, maybe even millions of years. But compared to the age of the universe, still just moments. I like to think of it this way. Imagine fireflies in a dark forest. Each firefly blinks for just a moment on one night and then is gone. The tragedy of the universe isn't that it's empty. It's that the party guests are arriving at different times. Two fireflies blinking on different nights in a dark forest will never see each other. The mathematics of this is sobering. The odds that technological civilizations would actually overlap in time is extraordinarily small. Now, we also have to think about communication. Suppose, just suppose, we did somehow make contact with an alien civilization through radio signals or something like that. How would we even communicate? Let me tell you a story. Suppose we were in a telephone conversation with a Martian or an Arcturian or something. We don't know where they are, and we'd like to describe things to them. Well, you might think, we'll start with something we both understand, chemistry. So you say, you take beet sugar, you see, and you put it in water, and it twists. But the Martian says, what's a beet? He has no beets up there. You see the problem? Or you might try to explain hand-deadness. Both we and the Martians, if we're going to do chemistry, need to understand which direction molecules twist. But here's something very interesting. We have no way of knowing whether the accidents of evolution that led to our molecules would have produced the same hand-deadness elsewhere. We have no way of knowing. It's possible that alien life, if it uses chemistry at all, if it uses anything like what we use, would have developed with opposite handedness. There's no inherent reason it has to be the same. So even in communication, these kinds of details become very tricky. But let's get back to the main point, visiting. Let's talk about flying saucers, since that's what people are often really asking about when they ask about aliens. I had a conversation some years ago with someone about this. They asked me, is it impossible that there are flying saucers? And I said, no, I can't prove it's impossible. It's just very unlikely. And they said, well, that's unscientific. If you can't prove it's impossible, how can you say it's unlikely? But that's exactly what is scientific. I should have said to them, from my knowledge of the world I see around me, I think it's much more likely that reports of flying saucers are the results of the known irrational characteristics of terrestrial intelligence. That is, human nature, human perception, human errors, misidentification, than of the unknown rational characteristics of extraterrestrial intelligence. That's the comparison you have to make. Which is more probable? Now, some of the claims about flying saucers are quite specific, and you can apply physics to them. People report objects that accelerate instantly from rest to enormous speeds. Do you realize what that would do? If you had a craft that could accelerate from 0 to, say, 1,000 miles per second in an instant, the G-forces inside that craft would be catastrophic. We're talking about thousands of GS. That would crush any biological organism. The materials themselves would be under enormous stress. And if something were traveling through our atmosphere at those speeds, the heating, the plasma formation, the sonic booms, these would be detectable, visible, unmistakable. It would be obvious. There are also basic optical and perceptual issues. You know, when people see bright lights in the evening sky, they often attribute them to UFOs. But have they considered Venus? Venus is the brightest object in the night sky after the sun and the moon. When you're in a moving vehicle and you see a bright light in the sky, there's an optical illusion. Your brain thinks you're still and the light is chasing you. The light seems to be moving faster. People see patterns in things because our brains are very good at pattern recognition, sometimes too good. We see faces in clouds. We see meanings in random noise. I'm not saying this to be cruel or to mock people. I'm saying it to point out what we should consider when we evaluate evidence. The question is always, what's more likely? Not what's possible, but what's probable. Now, here's something that I find remarkable. We could much more easily communicate with extraterrestrial civilizations by listening or sending radio signals than by expecting them to visit us. If life has evolved elsewhere and developed technology, they would almost certainly develop radio technology. It's a natural development. And if they're trying to communicate, radio is far more efficient than building spacecraft and traveling across incomprehensible distances. Think about it. Radio signals travel at light speed, instantly across vast distances. Spacecraft would take thousands of years. The comparison is obvious. The SETI program, the search for extraterrestrial intelligence, is based on this reasoning. And while we haven't found anything yet, the program is only a few decades old. The universe is billions of years old. We're like someone who's been listening to the ocean for a few minutes and saying, "I don't hear any whales." That doesn't mean there are no whales. The ocean is vast. But at least with radio, you can cover distances in a short time. You can't do that with spacecraft. There's another issue I want to address, something related to the nature of life itself. Life here on Earth is based on chemistry, carbon chemistry specifically, and our proteins and DNA have a particular handedness, as I mentioned. But more than that, we're based on a very specific set of solutions to the problem of being alive. We have 2 eyes, for limbs, a backbone. But these aren't universal requirements for life. An alien organism might look wildly different from us. It might have different sensory abilities. It might experience reality in ways we can't even imagine. If it did come here, we might not even recognize it as life. We might think it was a rock or a mineral or something we hadn't classified yet. And you know what? This points to something fascinating. If extraterrestrial life did exist, if it became intelligent and developed technology, the more advanced it became, the less likely it would look anything like what we imagine. The flying saucers in popular culture, with their humanoid proportions and visible lights and obvious metallic structure. These tell us more about human imagination and human biases than they tell us about the probable nature of alien spacecraft. When you're designing something to survive and operate in space, you think about efficiency, about radiation shielding, about the laws of thermodynamics. You wouldn't necessarily build it to be easily visible to someone looking up from a planet. You wouldn't use visible light unless it served a purpose. You have the entire electromagnetic spectrum available. Why would you choose the narrow band that happens to be what human eyes can see? It doesn't make sense. Here's what fascinates me, though. Despite all of this, despite the vast distances, the speed of light limit, the improbability of civilizations overlapping in time, the problems of communication, I don't think the universe is necessarily empty of life. In fact, I suspect the opposite. Given the number of planets, given that life arose very quickly on Earth under the right conditions, I expect life is common. Maybe even intelligent life is not that rare. But common in the universe and common enough to visit us are completely different things. The universe is so incomprehensibly large that you could have intelligent life on 1,000,000 planets and still be utterly alone. You could pass through entire galaxies of worlds and never encounter another soul, and you'd never know it. This is one of the profound lessons of understanding physics and chemistry at a fundamental level. You develop a kind of humility. You realize that your intuitions about how common things are, about what's likely, about what you see when you look up at the sky, all of these intuitions can mislead you if you're not careful. The universe doesn't care about our expectations. It follows rules. And those rules are often counterintuitive when applied to scales we've never evolved to understand. Now, I want to be very clear about something else. The fact that I'm skeptical about flying saucers, the fact that I think alien visitation is extremely unlikely, does not mean I'm dogmatic. I'm not saying it's impossible. If we found evidence, real evidence, not just stories or unexplained sightings, but actual physical evidence, something we could examine and study, and that withstood scientific scrutiny, then I would have to reconsider. Science has to be open to evidence. That's the whole point of science. But the evidence we have so far doesn't point to alien visitation. The reports we have are better explained by human perception, misidentification, and the tendency of our brains to find patterns. The physics tells us that visitation would be extraordinarily difficult, not just for us, but for any civilization in the universe. And the sheer improbability of timing, of 2 civilizations existing at the same time and being close enough to reach each other, makes it unlikely in the extreme. What I think is more probable, much more probable, is that if extraterrestrial intelligence exists, we might someday receive a message from it, a radio signal, some kind of transmission. That would be remarkable. That would tell us we're not alone, that intelligence can arise in this universe, that something else out there is looking up at the stars and wondering the same things we're wondering. And you know what else I think? I think that's enough. I think receiving a message, knowing that someone else is out there, would be one of the most profound discoveries in human history. We wouldn't need to meet them face to face. We wouldn't need their spacecraft to visit us. Just knowing that we're not alone, that would change everything. That knowledge would be a gift. But until we have real evidence, the honest answer is, we don't know. And that's okay. There's a lot we don't know. The universe is still full of mysteries, and I find that exciting. The fact that the sky is silent, the fact that we haven't found aliens yet despite looking for them, the fact that interstellar travel is so incredibly difficult. All of this should make us think more carefully about what we claim and why we claim it. That, to me, is the spirit of science. Not the claim to know everything, but the willingness to follow evidence wherever it leads, to think critically about probability, and to maintain a kind of intellectual honesty about the limits of our knowledge. We are, all of us, born not knowing anything. We have a very little time to change that. And in that time, we can either jump to conclusions or we can try to understand, really understand, how the world works. The universe doesn't care what we believe. It simply is. And that's both humbling and wonderful.